Okay, now I can go. All right, so again, I want you guys to understand, even though we're going to be solving a system by substitution, there's still only 3 answers that you can get when you go to solve a system. You're going to get 1 point. You're going to get no solution because they are parallel lines, and even though we're not graphing, we can still tell if they're parallel lines by the type of answer that we get. All right, or you're going to get IMS, infinitely many solutions, because they are the exact same line and they have every single point in common. Okay, so I just want you guys to realize that these are still the only answers that you're going to be writing down as the answer to your system, even though we're solving it by substitution now, okay? And just while I have you all here, I want to remind you guys that we will be taking a quiz on the Wednesday before Christmas break. So on Monday and Tuesday, we'll wrap up substitution method, we'll review for the quiz, and then we'll take the quiz on Wednesday, okay? But these are the only 3 answers that you can get on that quiz. All right, so we've learned how to graph. Now we're going to be doing substitution. In order to use the substitution method, you need to know what one of the variables is equal to. That is the entire basis of the substitution method. In order to substitute something in, you have to know what something is equal to. All right, so I've given you a list of steps to follow in case you need something to refer back to. Just really quick. First thing you need to do is to solve one of the equations for one of its variables if needed. Sometimes the problems are set up so nicely that that part is already done for you. You gotta love that, okay? Once you know what one of the equations is equal to, if you don't know what one of the equations is equal to, you're going to have to solve it by yourself. So guys, I need you to be smart about this. When you're going to solve one of the equations for one of its variables, try to avoid unnecessary fractions by picking the easiest variable to get by itself. And I'm going to show you how to do that because you do not want to make these problems any harder than they need to be, okay? So we need one of the equations to say x equals something, or we need it to say y equals something. We have to know what a variable is equal to. All right, then you're going to plug that value that you have found into the other equation and solve. That's how you're going to get your first answer. And guys, I'm not going to lie. You're going to work pretty hard for that first answer, okay? Once you get the first answer, though, to get the second answer, you just plug your first answer into one of the equations they gave you, and you're done, all right? But again, it's a process for sure. So I want to start with a very basic problem that is set up very nicely for you, okay? So let's look at the first example. If they ask us to solve this system by substitution, so they have clearly said you have to use the substitution method. All right, well, guys, look at the first equation. 6 times x minus 5 times y equals 1. Clearly, that equation is not telling us what x or y is equal to. But the second equation literally says x equals negative y minus 9. Now, I get it. I know that's not as nice as them telling us x equals 9. It's not as easy as that, but it's still telling us what x is equal to as a mathematical expression. So the first step is already done for us. We already know what one of the variables is equal to. So what we're going to do is we're going to take what that variable is equal to. I'm going to take what x is equal to, and I'm going to plug it in for x in the other equation. That was our substitution. We are substituting this expression in for x. All right, so guys, let's do it. Let's rewrite this equation. So it starts with a 6, and then it says times x. But we're taking x out, and we're putting this in for x. So times negative y minus 9, right? We're plugging that in for x. And then finish off the rest of the equation. Minus 5y equals 1. So guys, what it does is it leaves you with one equation that only has one variable in it. This equation only has a y in it, which means we're going to be able to solve this equation for y. So this should feel very normal for us. I am. Thank you so much, Emma. I forgot it first, and then I remembered. So thank you so much. Please, please always ask me, because my poor vote kids would be so upset if I didn't have this. All right? All right, so now we're going to solve. So we're going to distribute 6. We're going to get negative 6 times y minus 54 equals negative 5y. I'm sorry, minus 5y equals 1. Combine like terms. Negative 6y and negative 5y, that's really negative 11y's minus 54 equals 1. I'm going to add my 54 away like I normally would. and I'm going to get negative 11y equals 55. Divide by negative 11, and woo, we got it. We got our first answer. No, thank you, Hannah. No problem. No problem, Hannah. Y equals negative 5. Okay? All right, so now here's the thing. You do all that work, you kind of get excited like, oh God, thank God that's over. Let me go on to the next problem. But remember, you are solving a system. A system has two variables in it. It's missing two values. We only have one out of those two answers. We still have to get the second missing answer. So now what you do is you take the number that you got for y and you either plug it in for y into the first equation and solve for x, or you plug it in for y into the second equation and you solve for x. And guys, the second equation is much easier to plug into. It's already solved for x. So I'm going to take this equation and I'm going to plug in what I just found out y is equal to. So I'm going to plug my negative 5 in. So x is equal to, there's a negative sign in the equation. I'm plugging negative 5 in for y, so that's going to be negative 5, and then minus 9. A negative times a negative turns to positive, and then 5 minus 9, you find out that x is negative 4. So we didn't have to graph it, and we were still able to find an x and a y value that make both equations true. However, they still ask you to write your answer as an ordered pair. So the answer would still be negative 4, comma, negative 5. So on your homework tonight, you're going to have to write your answer as an ordered pair. Just make sure you put x first and y second. All right? All right, guys. That is a pretty nice problem as far as substitution goes because it was set up perfectly. It was set up where we already knew where one variable was equal to. So we just began that plugging in, that substitution step. Is everybody okay? Do you remember this from Algebra 1? Thumbs up if we're okay. Okay, let's do one where it's not necessarily set up perfectly for substitution right off of the bat. All right, look at this problem. Look at example number 2. If I'm going to solve that system using substitution, I either need to know what x is equal to, or I need to know what y is equal to. But guys, neither one of these equations right now is telling me x equals this, or y equals this. So that means you're going to have to make a decision. You're going to have to pick either the x or the y from the first or second equation and get it by itself. So there's options, guys. However, let's pick the easiest one to get by itself. The easiest variable to solve for will always be the variable who has a positive 1 or a negative 1 in front of it. Because when you go to solve for that variable, if you have to divide, everything in this world divides by 1 or negative 1. So you will not create any fractions for yourself along the way. So you're always going to pick the variable that either has the positive 1 or the negative 1 in front of it. So guys, if you look at the first equation, x has a 6 in front of it. We ain't solving for him. This y has a negative 1 in front of it. I think that would be a really safe option to get that variable by itself. All right, in this equation, x has a 3 in front of it. We ain't solving for that x. This y has a negative 1 in front of it. So that would also be a very safe option to pick to get that variable by itself. So if you ask me, we have two options. We can either solve this equation for y or this equation for y, and it should work out very nicely. So guys, it's a personal choice at this point. I can pick the first y, you can pick the second y, we're all going to get the same answer. I like the numbers in the top equation better than I like the numbers in the second equation, so I'm going to pick the top one just for that reason. All right, so we're going to take 6x minus y equals 2, and we're going to solve it for y because it's one of the easiest ones to do. All right, so it's minus 6x to the other side. That's going to leave me with negative 1y equals negative 6x plus 2. The only thing I have to do to get y by itself is divide that negative 1, and that's really easy because everything divides by negative 1. It's just going to change all of their signs. So I'm going to divide by negative 1, and negative 1. And then y will equal 6x minus 2. Okay, so now we've set the problem up. Now that we know what y is equal to, I can take what I just found out y is equal to, and I'm going to plug it in for y in the other equation. That's the important part, guys. You have to plug this in for the y in the other equation that you didn't use yet. You cannot plug 6x minus 2 into the equation that you solved. It'll leave you with like a false IMS or a false no solution, and we don't want false answers. So you have to go back to the equation that you haven't used yet. All right, so let's do it. Let's start rewriting that second equation. 3 times x minus, I'm not going to minus y because I'm plugging this in for y, but I have to make sure that I subtract all of it, so you have to use parentheses. So minus, plug 6x minus 2 in for y, and then continue on, equals negative 19. Okay, and again, what it does is it leaves you with one equation that only has one variable in it. This equation only has x's in it. So we're going to be able to solve this equation for x. So let's bring down 3x and let's distribute our negative. Negative 6x and then plus 2 equals negative 19. All right, I'm going to combine like terms. 3x take away 6x is negative 3x, plus 2 comes down, and it equals negative 19. Let's start getting x by itself. So we'll minus 2. Negative 3x equals negative 21. Divide by negative 3. Woo! We got our first answer. X equals 7. Okay. To get your second answer, you have tons of options. I can take the fact that x is 7, plug it into the top equation, solve it for y. I could plug 7 into this equation, solve for y, or even better, I could plug 7 into the equation that I made and solve for y. And this is already solved for y, so it's the easiest one to plug 7 into. So I'm going to plug 7 into this equation. So that means y is going to be equal to 6 times 7 minus 2. 6 times 7 is 42. 42 minus 2 is 40. So y equals 40. So if we did graph this, these lines would have met at the point 7, 40. So I'm really glad we didn't have to graph it because I don't want to graph anything until I get to a y coordinate of 40. That's a pretty big graph. All right. All right, guys, are we okay with that one? Because that one took a lot of work. You had to get a variable by itself first. You had to plug it in. You had to get an answer, take that answer, plug it in, get your second answer. Are we okay still? Everybody's all right? Okay, so those are the ones you're going to work the hardest for because that's got everything, all steps need to be done by you. All right, look at example 3. This is my favorite kind of substitution problem. If they're going to do one like this for you, these are the easiest. They are by far the best. All right, look at here. If they set up the problem like this and they ask you to solve it by substitution, look what you're going to do. Normally, in order to solve something by substitution, I need to know what x or y is equal to, right? Well, this time, they already solved both of the equations for y. This one says y equals this. This one says y equals that. And the beautiful thing about a system, guys, is that the y value that is missing from this equation, it represents the same missing number that is missing from this equation. So remember, the y in the first equation is equal to the y in the second equation. So if they're equal, if y is equal to this expression and y is also equal to this expression, well then what do these two expressions have to be to each other? They have to be the same. So all you have to do is set the two expressions equal to each other. When will 5x minus 2 equal 1/2 x minus 2? You just set them equal, and now it's like the easiest solving in the world. Now, guys, this one did have a fraction in it, so you do what you got to do to work with the fraction. If you want to rewrite 1/2 as 0.5 because decimals are easier to work with on your calculator, go right ahead. You do you. I'm going to use an old trick. I'm going to get rid of the fraction. Since 2 is my only denominator, I'm going to times all my tops by 2 to get rid of that fraction. It's just what I'm choosing to do. So 5x times 2 is 10x, minus 2 times 2 is 4, equals 1 times 2 is 2, divided by 2 is 1, that's 1x, which is x, and then minus 2 times 2 is 4. And now I'd rather solve this than anything that has a decimal or fraction in it. All right, here we go. So first I'm going to work to get my x's all on one side. So I'm going to minus my x to the left. That's going to get me 9x minus 4 equals negative 4. Now, guys, something weird's about to happen, and I want to make sure that we're all on the same page. When I go to move negative 4 away, I'm going to add it. That's going to get me 9x's equals, they canceled like I planned. What I didn't plan on is this cancels too, -4 plus 4. But guys, what number does it cancel to if nothing is there? It cancels to 0. And this is where students start to be like, oh, look, I got a 0. It's no solution. No, 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 no. There's still a variable in this problem. Continue to solve for x. This is not how you're going to get a no solution as your answer. We clearly still have a variable. I can keep solving. So divide by 9 and divide by 9, and you get x equals 0. 0 is a number on our graph that one of our coordinates could be. So it's perfectly okay to get 0 as an answer. Actually, I love it because it's a really easy number to work with. All right, so if x is 0, now I got to go and get my second answer. So I have two options. I could take 0, plug it into the top equation, solve for y. Take 0, plug it into the bottom equation, solve for y. I don't know about you guys, but I'd much rather work with the top equation. All right, so I'm going to take y equals 5x minus 2, and I'm going to plug 0 in. So that's going to be y equals 5 times 0 minus 2. That's 0 minus 2. That's -2. Y is -2. All right, so that means if these had been graphed, they would have met at the point 0, -2. They have the same y-intercept. Okay? All right, guys, how are we feeling? Everybody's pretty good? Again, to me, I love those ones. If they're going to tell me it like that, I just set them equal and I start solving. It's beautiful. Okay, so that's what it's going to look like if you're going to get 1 point as your answer. What is it going to look like if I get IMS or no solution now that we're not graphing? How am I going to be able to tell if they're the same line or parallel lines if we're not getting them in y equals mx plus b form necessarily? This is what it's going to look like when you get IMS or no solution as your answer. All right, so guys, look at example 4. If I'm going to use substitution, I need to know what x or y is equal to. Neither equation is solved for x or y. So I'm going to have to do that part on my own. We're going to get the variable that has a +1 or a -1 in front of it by itself because those are going to be the easiest ones. So guys, if you notice, this x has a +1 in front of it. That looks like our guy. That looks like the variable that we should solve for. Y has a +2. I ain't doing him. X has a +2. I'm not solving for that X. Y has a +4 in front. I ain't solving for that Y. So it looks like this X is our best option. So let's take it. So let's take X plus 2Y equals 3, and let's get X by itself. Let's minus those 2 Y's away. So X will equal -2Y plus 3. Okay, now that I know what X is equal to, I'm going to take what X is equal to, and I'm going to plug it in for X in the other equation, in the equation I haven't touched yet. Right there. I got to plug them in for that X in the other equation. So that's going to be 2 times, not X, I'm going to plug this in for X. So I'm plugging -2Y plus 3 in, and then I'm going to finish the equation. Plus 4Y equals 6. So we're looking good. I only have Y's in this equation. I'm going to be able to solve for Y. So let's distribute our 2. And then this is what's going to happen. I'm going to get -4Y plus 6 plus 4Y equals 6. All right, guys, this is where it's going to happen, and you're going to find out, like, wait a minute, this is not right. When you go to combine like terms and to continue the solving process, what happens to -4Y's and +4Y's on the same side of the equal sign? They cancel. There are no Y's left in this problem. So when your variable cancels out, see here, our number canceled. That's okay. When our variable cancels, this is when you're going to get an IMS or a no solution. But which one do I get? That depends on what is left in the problem. What's left? A +6 equals a +6. Guys, is that true? Does 6 equal 6? Yeah. If you are left with a true statement and no variable in sight, that means that they must have been the exact same line and they have every single point in common to leave you with that true statement. So this is what IMS is going to look like. You will get IMS when the variables cancel and the statement you are left with is true. All right. Well then, what's it going to look like when you get no solution? Look at this one. Okay, if I have to solve this system using substitution, I need to know what x or y is equal to. So it's going to be our job to solve one of them for x or y. You are going to pick the variable that has a positive 1 or a negative 1 in front of it. That's the easiest one. All right, he's got a 12. We ain't solving for him. He's got a 4. No, thank you. He's got a negative 3. Nope. He's got a negative 1. That's it. That's our guy right there. We are going to solve for this y in the bottom equation. So let's do that. Let's get y by itself. All right, I'm going to add my 3x's over. I get negative 1y equals 3x plus 6. I'm going to divide everything by negative 1, which is nice because everything divides by negative 1. It just changes their signs. So now y equals negative 3x minus 6. Okay, so now we're going to take what we just found out y is equal to, and we're going to plug it in for y in the other, oh, hold on, don't follow me, in the other equation. I went to the wrong one. All right, so we're going to plug it in for that y right there. Let's do it. So 12 times x plus 4 times, take y out, put what we just found out y is in, and then it equals 3. Okay? All right, let's bring down the 12x, and let's distribute the 4. So I get negative 12x, there it is, and then minus 24 equals 3. So when I go to combine like terms, what happens to a 12x and a negative 12x? They cancel. There are no more variables left in this problem. I am left with the statement that says negative 24 equals 3. Does negative 24 equal 3? Not even close. That's a no solution. That means that these must have been parallel lines and there's no x or y value that will make both of these equations true, which is why you're left with an untrue statement. So this is your no solution. So it's kind of nice because you kind of get to just stop. You don't got to go keep solving. You don't got to plug anything back in. You get to just stop. But remember, you will only get INS or no solution when the variables disappear from the problem. That's when you get these kinds of answers, okay? All right, how do we feel, okay? I just tried to go over every single type of scenario with you just to make sure that you're prepared for the homework, okay? All right.